This time on Battle Factory, a non-lethal bullet that's targeted for training. A ceremonial sword that still leads the charge. And a supersonic dogfighter that does it all. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. This chunk of carbon steel will be honed and hammered into a military icon that's as old as war itself. Used as the primary weapon in battle for over 5,000 years, over time, the sword became lighter, sharper, and even more deadly. However, by World War I, fighting style had changed. Hand-to-hand combat was replaced by trench warfare and the machine gun. The sword saw little action. But 100 years later, it still performs a ceremonial role, symbolizing rank, courage, and honor. Today, every British soldier who achieves the rank of officer has the privilege of wearing a sword. This workshop south of London is one of the last where cavalry swords are handcrafted individually, using techniques that are centuries old. Designed in 1912, the cavalry sword breaks down into the handle, the guard, and the blade. The blade begins as a billet of raw carbon steel. Carbon has been used in making swords for over 1,000 years. It's ground into its basic shape and dipped into oil. Then a groove called a fuller is ground into the flat side of the blade. Also known as a blood groove, the fuller is designed to make the sword lighter and easier to pull out of the target. The blade is baked in an oven to harden the steel. Then it's cooled or quenched in oil. The hardening process sometimes causes warping, so in order to straighten it, it is first heated with a blowtorch. Using a press that looks like it hasn't changed much in centuries, the warps are pounded out of the blade. Then the bladesmith finishes the straightening with a hammer and an experienced eye. The blade is then tested to make sure it's flexible enough to bend without breaking. And it's struck against a rounded metal surface to make sure it can take the impact without cracking. Finally, the blade is polished to a high mirror finish. While the cavalry sword was obsolete by World War II, one eccentric soldier, British Lieutenant Colonel John Churchill, maintained that any officer going into battle without his sword was improperly dressed, and he became known for charging into battle wielding his sword. His nickname became Mad Jack. Etching swords is an art that's been practiced without much change since the Middle Ages. Thick red paint fills the patterns in a steel mold. Then it's transferred onto paper. This cavalry sword is marked with a decorative pattern, and the royal cipher, the ER2, stands for Queen Elizabeth II. The paper is gently rubbed onto the blade and peeled off, leaving behind the painted pattern. Then the blade is dipped into an acid bath for 20 minutes. The paint is acid resistant, so when the sword is removed and rinsed, the paint is scraped off, leaving the ornate pattern etched in the blade. This technique has been used for hundreds of years. The cavalry sword has an ornate guard that was originally designed to protect the swordsman's hand. Its basic shape is traced onto a metal sheet and cut. Then, the pattern is silk screened on with paint and dipped in acid. Once the pattern has been etched on, the guard is pounded into shape on a press, then hammered home by hand. The traditional wood handle is wrapped tightly in actual stingray skin, a unique leather that's been used for centuries. Once it's glued and dried, the skin is painted. Finally, silver wire is wound into the handle's grooves to give it a good, solid grip. Mad Jack, the last soldier to carry a sword in World War II, was ordered in September of 1943 to capture a strategic German-held post in Salerno, Italy. Hopelessly outmanned, Churchill crept through the base, swooping in on unsuspecting soldiers and drawing his sword. Mad Jack captured 42 Nazi soldiers, took the German post, and earned himself a Distinguished Service Order. Once all the components have been created, the blade is locked onto a table vise and the sword is assembled. The guard and grip are slipped onto the blade and bolted on tight. Then the pommel, an ornate cap, completes the sword. The sword hasn't been relied upon in combat since the exploits of Mad Jack Churchill, but it will forever remain a part of military dress and military history. Coming up on Battle Factory. This bullet won't kill you, but it will make you stronger. And a scrappy little dogfighter that's been Top Gun for 40 years. These aluminum rods and plastic pellets will be molded and machined into simulated ammo that fires like the real thing. When it comes to training options, this is number one with a bullet. Urban warfare is a harsh reality of today's military theater. Adrenaline-fueled operations that take the soldier directly into the enemy's house, facing attack from behind doors and around corners. By late in World War II, Allied troops needed to train for urban warfare in a real-world setting. So, residents of the English village of Imber were asked to leave their homes so U.S. troops could train for D-Day on their streets and in their houses. In close-quarter combat, panic, fear, and blind aggression are inevitable. And the closer the soldier can get to the real thing, the more effective the training will be, right down to taking a bullet. Simulated ammunition is a cross between a bullet and a paintball. It fires like real ammo, it hurts, it leaves a mark, and it lets soldiers know with dead certainty if they've hit their target or become one. The man marker simulated ammunition breaks down into the components, the cruciform dome, and the slide. Made from rods of aluminum, the slide will house the component parts of the simulated slug. The rods are dropped onto a conveyor belt and turned on an automated multi-spindle lathe, which spits out 50 finished slides per minute. Every slide passes through a high-speed sensor, which analyzes it for quality and measurement. If it detects the tiniest speck of debris, or if the size is off by even 0.001%, the entire batch is rejected. Then the slides are laser engraved with the production date. The plastic cruciform dome is the outer casing of the bullet. First, plastic pellets are put into a dryer. Then, they're molded to form the little plastic domes that make up the tip of the simulated ammo. This process outputs 500,000 domes every 24 hours. Once the components are completed, they're conveyed to a robotic assembly line. Each of the bullet's 10 parts is dropped into individual hoppers and then fed into the machine. The slide is inserted with the projectile charge, a firing pin ball, and the rear power load. Then, an inertia applicator ball is installed along with the marking compound that leaves its telltale spot on the target. Finally, the plastic cruciform dome is capped on top. They may be simulated, but these bullets are fired from real guns so that soldiers can train on the same weapons they'll be carrying into combat. After installing a conversion kit into the rifle's action, the magazine, loaded with simulated bullets, is ready for testing on live targets. The training ground is laid out for fishing, short form for fighting in someone's house. A firefight with simulated ammo gets the soldier used to being shot at. The projectiles break upon impact and leave a mark. And there's no mistaking the feedback. A red dot on your chest means you've been hit. In 2013, the U.S. Army built a 300-acre city to use as a facility for urban warfare and house-to-house confrontations. Simulated ammunition plays a critical role in these scenarios, and the way a soldier reacts to a simulated firefight could make the difference between walking out of that house and getting carried out. Coming up on Battle Factory. Whatever the mission, this lightweight skyfighter earns its wings. Brain power and firepower transform 8,000 kilograms of computer-controlled machinery into a legendary dogfighter with the best fight and flight record in the sky. The F-16, known as the Fighting Falcon, is equally effective in air-to-air combat and air-to-ground attack. And at Mach 2, if you hear the F-16 coming, it's already too late. During the Vietnam War, the United States sustained dramatic losses. The F-4 Phantoms often struggled to take down the supposedly weaker Soviet MiG-21s at close range. So a maverick group of engineers known as the Fighter Mafia was determined to design a lightweight maneuverable jet that could handle both air-to-air and air-to-ground operations. And in 1974, they pulled it off. 40 years later, the modern version of the fighter jet is still almost identical in shape and size. The secret to its agility and speed is a sleek, compact fuselage. The F-16 breaks down into the aft, the center and wings, and the forward. The forward fuselage is the nerve center of the airplane and takes over 9 months to build. It houses the cockpit, gun trough, fuel tank, and the piloting and navigation systems that were a true innovation when the F-16 first took to the air. The forward fuselage starts as an aluminum shell. In the electrical harnessing station, over 70 kilometers of wire are strung through the fuselage, connecting the cockpit controls to navigational and weapon systems. Each wire is hung before install to allow it to stretch. A wire that shrinks or recoils mid-flight could be catastrophic. The F-16 is a fly-by-wire aircraft, which means that the pilot's commands are relayed electronically instead of employing the hydraulics. This decreases the number of moving parts, making the plane lighter and safer. When it was first introduced in 1974, pilots needed to get used to the feel of what they dubbed the electric jet. Once the wiring is complete, the forward is transferred across the factory to a test bay where every electronic and computer component will be analyzed to make sure the fly-by-wire system is functioning perfectly. Every control panel component is tested, from radar display to the targeting and navigational systems. They test the heads-up display, which projects navigational data and weapon status right onto the canopy glass. A real-world computer interface that shows the pilot where he is and where to target his missiles. Then the bubble canopy is attached and tested. It's made of high-strength polycarbonate that gives the pilot a 360-degree view. Finally, the forward is hoisted over to the flatbed and put aside for the mating process, where it will be joined to the center and aft sections of the plane. Since the 70s, the F-16 has always been known as the Fighting Falcon, but its sleek, compact forward fuselage earned the plane a new nickname, the Viper. Because of daring missions like in May of 2011 involving aggressive diving, quick strafing fire, and deadly use of missiles, the bird became a snake. The center fuselage houses the landing gear, the in-flight refueling system, and the wings. The center starts as a barrel shape. Panels are screwed onto the frame to keep the structure together. Next, bulkheads that act like ribbing are built around the barrel. These will allow room to house the fueling system, the electrical wiring, and make space to attach the landing gear. A metal skin is attached to the outside of the structure. The aluminum skin is made to be subjected to the extreme temperatures and stress caused by flying at supersonic speeds and at altitudes up to 15 kilometers in the air. Once complete, it's set aside to wait for mating. The aft fuselage houses the exhaust port and the small fins and wings that help to steer and stabilize the plane. Once all the pieces of the fuselage are completed, they're transported to another hangar to be assembled. On a mission in Afghanistan, high above the desert floor, F-16 pilot Major John Caldwell spotted a small unit of U.S. and coalition special forces being ambushed by almost 100 Afghan insurgents. He decided to take them on. He armed his F-16's Gatling gun and braced himself for the fight of his life. Coming up on Battle Factory, the F-16's exploits earned the Fighting Falcon its nickname. While on a routine patrol, F-16 pilot Major John Caldwell caught an ambush in progress. A small Special Forces team had been attacked by an insurgent cell and were fighting for their lives. Caldwell swooped in and laid down strafing fire with his aircraft's 20mm gun to create distance between the insurgents and Special Forces squad. Then he pulled his aircraft up, came back around, and dropped a satellite-guided bomb on the attackers, neutralizing the ambush. Caldwell was awarded a Distinguished Flying Cross. The Fighting Falcon lives up to its nickname, the Viper. In the mating station, the completed pieces of the aircraft's fuselage are dropped into a fixture to be joined together. It's a precise and painstaking operation. Next, the tricycle landing gear and vertical stabilizers are installed. The fuselage is hoisted onto a ceiling-mounted crane, and the horizontal stabilizers and wings are installed. The radome, or nose of the aircraft, houses the F-16's state-of-the-art radar system, which detects standard environmental elements like wind and airspeed. The F-16 is powered by a turbofan engine, which can accelerate the aircraft to more than twice the speed of sound, or over 2,200 kilometers per hour. The F-16's smart, modular design means that the engine can be removed, serviced, and replaced easily in any airfield in the world. Once it's assembled, the F-16 is transported to an environmentally controlled paint hangar. The temperature is kept at exactly 23.9 degrees Celsius, and the air is filtered of debris, which can cause millions of dollars worth of engine damage. The classified paint formula contains rubber, which masks the aircraft's heat signature and reduces radar detection. Once it's painted, the F-16 is ready to hit the runway and take to the air. Since its initial production in the 1970s, over 4,500 F-16s have been produced for 28 different nations. For 40 years, the Skyscraper has proven to be the best fighter in and beyond its weight class, defending its reputation as the dogfighter that does it all. The F-16 is never coming down.